So the quirk about this method is that since these perms only move 4 pieces at a time, we can easily plan out the entire solve from the beginning, memorize that plan, and execute it while blindfolded. Recall that we start by solving edges. So basically you can just choose any orientation to place the cube, preferably something you're used to so the setups are easier. The right edge is where you start, since both J and T perms swap that edge. And since the perms also swap the right corners, we want to keep the cube in sort of the same orientation throughout the solve, so that these corners go back and forth between each other. For our purposes, we'll refer to each edge as the top face colored followed by the other color. So this top face will be the primary color. So for example, this would be green, red, and this would be yellow, red, which is incidentally already in place. So first we'll start by essentially setting this to be the right, this to be front, and this to be top for this particular solve. And that means the first piece we want to sort of orient is going to be green-red. How we're going to do that is essentially move the green-red position up to either this position or this position in order to shoot this green-red piece across into the correct placement. And in order for us to do planning, all we have to do is essentially follow where the piece is supposed to go. So starting with green-red, we can sort of look for the green-red position between the green and red centers. And when we match it over here so that green is primary, that means we're going to replace it, sort of swap it, with white-green eventually in the first swap. And so then that means we can basically write down, so first we want to swap to the green-red position, and then we will want to swap to the white-green position, and then we can keep following that. So white-green is down here, so then it would replace it with green-orange, and then keep doing that. Green-orange comes around to orange-blue, and then orange-blue comes around to white-red. White-red goes around to yellow-blue, and yellow-blue goes to orange-white, and then orange-white goes down here to yellow-green. So notice that if we go to yellow-green now, it's going to be green-red, which we've already done. The problem here is that essentially we're always going to be using this as the shooter position to get it to go somewhere else. But because yellow-green already belongs in this position, unless we're all done with all 12 of the edges, then we can't actually execute anything to put yellow-green where it belongs without disturbing anything else. So once yellow-green is in this position, we have to sort of check whether all of the other edges are already complete. And unfortunately, it's not. So we can sort of choose any edge that hasn't already been set into a position where yellow-green can be put temporarily. And since actually orange-yellow, we haven't placed orange-yellow in its correct position yet, so we can sort of just put this piece, the orange-yellow position piece, down here, and then shoot the yellow-green into that position before resetting it. So that will start another cycle in which we can complete the rest of the 12 edges. So how that's going to work is, since we want to put the yellow-green edge first into the orange-yellow position, that's going to be our next step in the process, the position that we want to swap it to. And then we'll be able to say, in that particular position, we can see that the red-blue piece is in the orange-yellow position. So that's going to be the actually next physical piece that's going to be inside of this shooter position. So then we follow up with red, blue, and then after red, blue, we have blue, white. And then after blue, white, we go up here to orange, yellow. So orange, yellow should sound pretty familiar because we just swapped it into the orange, yellow position. Now that we're ending with the actual physical orange, yellow piece, we know that our next cycle is complete. And basically the orange, yellow piece will be swapped with the yellow, green piece so that they are both put back into the positions they need to be in. And so essentially we temporarily placed the yellow, green in the orange, yellow spot. And then now we're finally placing the physical orange, yellow piece and swapping it with yellow, green so that both of the final edges are complete. To check whether we've covered all of the edges, we can sort of count the number of distinct edges that have appeared in our list and make sure it's equal to 12. If it isn't, either we got lucky and an edge or two were already where they belong. In this case, yellow, red was already in position, so we have 11 distinct edges in our list. Or the other option, if you are missing more than that, is that you missed another cycle of edges to swap. So you would have to find another sort of edge that wasn't already in place and place the yellow-green piece there temporarily and start another cycle. So in this case, we have 11 distinct edges placed and the yellow-red is already in position, so this sort of edge plan looks to be good. Alright, so our next step is to plan out the corners. So the first thing to note here is that you should count the total number of swaps done in the edges plan, which in our case is 11. Note that yellow-green doesn't actually denote a swap because it was replaced by orange-yellow to temporarily move that edge piece out of the way. And since we swap 11 times and 11 is odd, the corners will actually be switched from their current starting configuration. Because if you do JPerm once, these will be swapped, and then if you do it twice, then they'll be swapped back to their original position. For any odd number of edge swaps, this means that these will start off in the opposite sort of configuration to what you see right now. So essentially what will happen is the green, red, white piece will be over here, and the red, green, yellow piece will be over here. And also, you can sort of take a look and notice that this white, green, orange piece is already in position. So there's one less corner we will need to worry about for this solve. So first, since the corner perm, let's start with red, green, and yellow. As with our previous edge solve configuration, let's just keep everything the same. This will basically start us off with this corner as the shooter position. And we will be denoting the primary color as the one towards the back of the cube. So in this case, we have a blue, white, red piece. Doesn't quite matter the order where we specify the latter two colors. It's just the blue is the primary color on this corner piece, and it has all three of these colors on it. So basically, we do sort of the same thing as the edge planning. We'd have the blue, white, red, and then we want to follow it to the position where it should be in. So blue, white, red's down here. So then our next piece that goes in will be yellow, green, orange. Since blue is the primary color, and then it'll map to yellow being the new primary color on the next piece. Alright, and then we have yellow, green, orange, and then you're going to follow it over here. And you're going to want to say that the next piece is going to be red, yellow, green, but actually recall that these two corners will actually be swapped. So it's not actually going to be the red, green, yellow piece over here, but instead the green, white red piece, since it will actually physically be back here once you start the corner swaps. So we have green, white, red instead, and then we follow it down to green, white, red to get white, blue, orange, and then we go around to white, blue, orange and get blue, yellow, orange. And blue, yellow, orange is actually the same piece that fits inside the actual position of the shooter location for this cube orientation. So that means since blue, yellow, orange is already sort of where it belongs, however, we've only so far placed 5 corners and not 8. So we need to keep going by placing it again in a temporary location that we haven't completed yet, and then keep going. So let's find a temporary location where we haven't already sort of placed the correct piece there, and one of those would actually be the yellow, red, green area. So yellow, red, green, this piece will actually be in the yellow, red, green position. So you can sort of see that yellow, red, green this is the correct position to put the yellow, red, green. However, red will be on top and not yellow, so that this will be in the correct position but an incorrect orientation. So essentially that means we will have to use 2 sets of perms to sort of rotate this back into the correct orientation and the position. How this will be done is, since we have the blue, yellow, orange up here, we can first denote the position to swap the corner in. And since it's easiest to sort of just have this come down, the right come down 90 degrees, and sort of swap this corner with this corner, then that means this will actually be in the yellow, red, green position. And the yellow, red, green position will give us a red, yellow, green physical corner. So first we swap into the yellow, red, green position, and then the piece that will actually get swapped there is red, yellow, green. And then we will basically swap it back into this position using red, yellow, green as the notation. And then because the blue, yellow, orange piece will have sort of temporarily resided in this position, and after swapping back the red, yellow, green piece, the blue, yellow, orange piece will actually be swapped back into its correct position. However, you'll notice that we've only placed 1 additional corner here. So we're still not done with only 6 corners out of 8 placed. So we need to find the next corner that we need to temporarily place the back corner here with. And that would be found with yellow, red, blue. So yellow, red, blue up here, you can see that this corner is also the correct position but the wrong orientation. So same thing, we would need to do the 2 versions of a perm, the corner perm, to get this into the correct orientation. So then first we can try to essentially swap into the yellow, red, blue position, and we would get the blue, yellow, red edge piece out of it. And then after doing the perm 2 times on those things, we would have succeeded in placing all 8 corners where they belong. So this is kind of a more convoluted example than usual, since the two corner pieces actually started in the right location but the wrong orientation, so it takes an extra step for each one to get resolved. Alright, so now that should take us to 8 distinct edges that we have successfully placed. So we can check if that number is correct by looking through our list. So we've actually swapped 7 distinct corners, and then an additional one including the white, green, orange corner, which we didn't have to move, which was back here. The number of swaps here is also even, so that the two edges back here won't get messed up when you're doing the corner perm. So since you're also swapping it each time you perform the permutation. And if you end up with an odd number of swaps in this step, you just basically need to check your logic again, because there's probably something that went wrong while you were tracing the steps. Now that we have the entire solve planned out, how you memorize it is kind of up to you. So some people are great with spatial memory and can visualize a path from one edge to another and one corner to another. Others do better by assigning relevant names to each piece orientation and memorizing a short story or mnemonic with those words in order. I find it a helpful exercise if you go through and name your own pieces with things that make sense to you, but I will also link the names I use in the video description for those interested. And for the purpose of the tutorial, I will keep using the full color name we used during planning. Now that we have the planning part done, let's get to actually solving the cube.